Meron tayo ditong bumbilya. Firefly basic. 3 watts. 100 to 240 volts AC. So siya ay AC. 240 volts or 220 volts. Ay, ano na naman ang balak mo dyan? Pailawin natin ito. Gamit ay 12 volts battery. Paano yung ilaw? Testingin muna natin kung siya ay 220 volts. Tingnan natin yung outlet natin. AC. AC. (232.2 AC). Diba? Sa atin socket outlet. Tingnan natin Ayun, di ba? 220 volts siya. Nakalagay ng bumbilya sa transformer. Sukatin natin yung battery. DC battery. DC. 12.30 volts DC. Okay? Kabit natin. Testing. Ayun umilaw yung bulb. 220 volts sa 12 volts DC. Tingnan natin yung battery kung ano ba ang voltage niya during the operation. DC 12 medyo nag-drop out 12.0706 DC. Dito naman sa transformer, AC na yan, AC. Tingnan natin. (146) 145. Hindi makita. (147 volts AC). Yan di ba? Hindi man siya 220, 147 volts AC. Napailaw niya yung 220 volts lamp. We have now this figure 1 inverter, 12 volts to 220 volts. Schematic diagram. Our objective is to turn on the 220 volts lamp by using a 12 volts battery. So here in our circuit, we have two MOSFETs, and then the battery, transformer, then biasing resistors, and the lamp. So, in order to simplify the operation of the circuit, we need to draw let us draw the block diagram. First, we have the battery. This is the battery. Then, from the battery, there is a transformer. After the transformer, we have this inverter, and then inverter, and then the output lamp. Okay? Battery, transformer, inverter, lamp. Battery is the source. What is the source of battery? DC. And because of the configuration and with the use of this transformer, we can able to create an AC. So after the inverter and the transformer, vice versa, we have now the AC. From DC becomes AC and will turn on the lamp. How can we create the AC from DC, from battery? So we need to trace the current. So when there is a battery here, 12 volts, current flows into the center tap. So there is a center tap of transformer. This is 12 volts, 0 volts, 12 volts of the transformer. And then current flows into the center tap. It creates a two current flows. Current flows from 3 to 1 or in a counterclockwise and then clockwise. In theory, when we are saying clockwise, it refers to we are creating a positive voltage. How about the counterclockwise? It is the negative voltage. So with the use of transformer, we are creating a positive and negative voltage. And then feeding it to the, let us see this clockwise, feeding it to the base, to the gate, to the resistor, and then to the gate, switching this MOSFET on. Remember that this is a biasing resistor. We need this in order to so that there's a voltage developed into the gate, making this MOSFET to turn on. It's around 2 volts. We need just around 2 volts to turn on this MOSFET. And so the current will now flow from 3 to 1 and then drain to source, switching this MOSFET on. So what is the purpose of the MOSFET? It is serve as a switch. So from here, there is no current that will flow into the drain to base as long as there is no triggering or there is no triggering current to the base of the gate. So in our first analysis, this one is the first one to conduct or to switch on. So that's why we have this. Since this is a counterclockwise, we have a negative voltage. We're going to draw that. The 0, that is the ground, and then the negative voltage is located somewhere here. A negative voltage below the 0 line or the 0 ground reference. And then looking back into the circuit, at the same time, current flows into the 3 to 1. This is counterclockwise, feeding to the resistor or switching this MOSFET on, since there's a current that flows into the gate, into the resistor gate, causing to develop a voltage across gate to source. So when there's a voltage developed across gate to source, it is this MOSFET will switch on. So it will switch on now. The current from here, the other side, from the clockwise, will now flow from drain to source, from the battery to the transformer, from drain to source. So it will switch on. And what is the voltage developed, or what is the voltage created? This is, if this is the 0 line, a positive voltage on. So at the same time, they are creating a negative voltage and a positive voltage. So in short, we have this a positive and a negative voltage created. Some sort of square wave positive voltage and negative voltage, making this an alternating current. So what's the purpose of the MOSFET? It serves as a switch. It will continuously, or it will it will oscillate. It will oscillate and switching this MOSFET on and off. If this is on, this one is off. This is off, this one is on. So there is a creation of positive and negative voltage. And what happened to what is the battery voltage? Okay? During the operation, it is around 12.07. There's a voltage drop. There's a loss because of the transformer. And then what happened to the voltage developed into the coil of the transformer? It will, due to the induction, it will stepping up the voltage into, should I say, a big alternating current in the form of a square wave. This is in a zero or reference ground, and then there is a positive voltage and negative voltage. So from small alternating current of square wave, due to the induction, we have now much bigger, which is capable of turning this LED lamp. It will turn on the LED lamp. But the voltage developed is around 147 volts AC. Why is that not 220 volts? In our circuit, we are having 220 volts. That is the bulb. 220 volts referring to the bulb. Okay? So this 147 volts AC generated from the inverter is capable of turning this LED lamp on. Although it is not 220 volts. Why is it we are not capable of producing 220 volts? Because we have no separate oscillator. We have just an oscillator, at the same time a driver of the transformer. We cannot control the oscillation of the MOSFET. We have no separate oscillator. That's why in this case we just have 147 volts AC, and due to the transformer loss, there's also a voltage drop, 12.07 volts DC into the battery. So we now created alternating current by creating a negative voltage and a positive voltage due to the switching this MOSFET on and off. Remember, when we have a base voltage here, due to the current that flows into the resistor, we're switching this on, and then at the same time it will switching this on into opposite direction. Remember, a positive and negative voltage in an opposite direction. And the zero is located into the middle. That's the reference voltage. The zero. There's no offset. Just the zero in the middle. So we created a forward and a reverse voltage into the secondary. Actually, this is not a secondary. This is a primary. We just invert the position of the transformer.